Hello guys, this time we'll talk about how ionization influences the pH. What are the reversible equations and what is the ionization constant? First, let's talk about pH. So we all know that pH is a scale from 0 to 14, where from 0 to 7 we have an acidic medium, at 7 we have neutral conditions, and from 7 to 14 we have a basic medium. The pH only depends on hydrogen and hydroxide molar concentration in the solution. If we have the same amount of these ions in the solution, we have a neutral pH. If there are more hydrogen ions than hydroxide ions, we have an acidic conditions, and vice versa. If we have an acid present in the solution, it will ionize into the ions. Let's take HCl, which is a strong acid, and compare it to the weak HCN acid. When hydrochloric acid ionizes, it is an irreversible process. That means that if we have 100 molecules in the solution, all 100 molecules will become H plus and chlor minus ions. Because the water has a neutral pH, we increase hydrogen ions in the solution, so the pH will become acidic. The same goes for hydrogen cyanide. However, the process itself is reversible, which means if we have 100 HCN molecules, only 10 or maybe 50 molecules will ionize into ions. We don't know the exact number, but we can say that this acid will produce fewer H plus ions, which means that pH will be acidic, but not as acidic as an HCl solution. If you want to learn how to write ionization equations, I leave a link in the description. All acids have an ionization constant, which is marked as a K with an index A, which stands for acid. Basically, it shows how much acid likes to ionize. The higher the ionization constant, the stronger the acid, and the lower its pH. Hydrochloric acid ionization constant is 10 million, but for HCN, the number is a lot smaller, only 6.2 times 10 to the power of minus 10. So because the ionization constant is so small, hydrogen cyanide is a weak acid. pH depends on the molar concentrations, because different amounts of hydrogen ions will be produced in ionization. If we take 0.1 molar concentration of hydrogen chloride and hydrogen cyanide, their respective pH will be 1 and 5.1. pH depends on the ionization constant. The higher the constant, more hydrogen ions will be in the solution, and the lower the solution pH will be. The same could be said about the bases that are on the different ends of the spectrum. Sodium hydroxide dissociates into ions completely, so its dissociation constant is huge. The same cannot be said about ammonia. Its dissociation constant, Kb, B stands for base, is 1.8 times 10 to the power of minus 5. The respective pH of 0.1 molar solution is 13 and 11.13. So the takeaway from this lesson is that pH entirely depends on how many hydrogen or hydroxide ions are in the solution, and it depends on the ionization constant.